आवाज आ रही है मेरी? Am I audible?
Yes,
Yes,
sir.
Hello. Screen is visible.
yes, sir.
Ozonolysis we did. I think last topic was ozonolysis. Correct? What is left after ozonolysis? We did ozonolysis, I guess. So next is alkyne. What is today's date? Morning 6:21 a.m. Next time it should be maximum like 6:05 a.m. tomorrow. Not every day you will have class, whether it is Sunday or other day. Same routine. Okay. And we are doing alkyne. Alkyne, in this case, you have triple bond, carbon-carbon triple bond, and you know that. Sania, what is the hybridization in this case?
Sir, sp hybridization.
sp hybridization. If, uh, Pratigya, you have two double bond of a carbon, what is the hybridization of this carbon?
SP.
sp. Okay, so this thing is important. If carbon have two double bond attached, then it is sp hybridization. Anvita, what is the general formula of alkyne? CnH 2n minus 2. It, it helps you to identify the bigger compound. Example, if you have two carbon, then CH triple bond CH. So carbon 2, hydrogen 2 2s are 4, minus 2. Correct. Here, this molecule CH triple bond CH, which is ethyne, is also known as Barinder. What is the another name of this ethyne? Acetylene. Remember, when you see ene in the end, you feel that this is alkene, but no, acetylene is alkyne. Okay. What is the use of this acetylene? It is used in the arc welding. How this is used in arc welding? Because we form oxyacetylene flame. Example, if you take acetylene, react with oxygen gas, CH triple bond CH, then what will happen? Oxyacetylene will form, and this oxyacetylene will help in the arc welding flame. I'll show you this. This is oxy acetylene whole system together. This black color cylinder is oxygen cylinder. Red color is acetylene. These white color are the regulator of gas, both acetylene as well as oxygen gas. Got it? Understood?
Yes, sir.
Yes, sir.
Have you seen any of you this, like how arc welding work in the real life? Like, have you seen before in class, like any video? Anvita?
No, sir.
Okay, okay. So that's why even sometime I forget to show, but try to get this idea because to benefit one, you get real life example. Second, most of time when you see real life example, there are high chance it can be asked in the NEET exam. And third, of course, you remember for a long time. Parinder, if we have sp hybridization, what will be the bond angle? Parinder, 180-degree. Shape will be linear. Okay? Shape will be linear, 180-degree. And how do we know that this is given in the chemical bonding chapter, where you get idea based on the hybridization. Here you have hydrogen, here you have hydrogen. So this bond angle is 180 and linear. Pratigya, if you take bond enthalpy in triple bond compared to double bond or single bond, is it more or less? If you take bond enthalpy in carbon-carbon triple bond, carbon-carbon double bond, or carbon-carbon single bond, where you have maximum bond enthalpy? Pratigya, triple bond. Because you require maximum energy in triple bond to break the bond. Minimum in single bonds for this. Chandana, what will be the bond length order?
Sir, carbon-carbon single bond is greater than double bond and triple bond.
Okay. Next, come to the preparation part. We have limited preparation. Only two preparation is given in our NCERT. Preparation of alkyne, and both are easy. At least one you have done before. And first is from the calcium carbide. So what we take? First, we take calcium carbonate. If you take calcium carbonate and you heat it, सानिया ये कैसे टूटेगा?
So calcium carbonate on heating gives calcium oxide and CO2.
Without. Now this calcium oxide will react with the coke. And when you heat this, it will form calcium carbide and carbon monoxide. Pratigya, what is the name of the calcium oxide? क्या नाम है
limestone,
Quick lime.
quicklime.
This is coke and calcium carbonate is limestone. This is limestone. Okay. Now, this calcium carbide, when react with 2H2O, what should be the product, Anvita? Remember, in this, you can prepare only acetylene, nothing else. Okay, only acetylene you can produce in by this process. Why? Because in carbide you will have only two carbon. Barinder, what is the smallest alkyne? Barinder, Barinder सो तो नहीं गई?
No, sir.
हाँ, स्मॉलेस्ट अल्काइन में कितने कार्बन हो सकते हैं?
Do.
हाँ, so smallest alkyne contain two carbon, and that is the minimum number of carbon you can have in alkyne. Second, from the vicinal dihalide. Chandana, what is the difference between the vicinal and geminal?
The functional group attach adjacently and oppositely.
And in geminal,
In geminal, it will attach opposite.
it will attach on the same carbon. If both the functional group attach on adjacent carbon, it is vicinal. If both the functional group present on the same carbon, then it is geminal. See here. Got it? Here you will do dehydrohalogenation. Pratigya, what is dehydrohalogenation? Pratigya, what is dehydrohalogenation?
Removal of halogen. Hydrogen
Removal of hydrogen and halogen. So D means removal, hydro means hydrogen, halo means halogen. This is beta elimination reaction. Shades of rule given in the class 2. So, Anvita, if we have this CH2, the X, then here you have hydrogen X and another hydrogen. If it react with KOH, what kind of KOH it should be? Is it alcoholic or aqueous? Anvita, alcoholic. If you take aqueous KOH, then OH will replace halogen. If you take aqueous, then OH will replace halogen and it will be substitution reaction. But here we are talking about elimination reaction. So elimination can happen only in the alcoholic KH. So what should be the product, Anvita? Removal of halogen and hydrogen from the beta carbon. Hydrogen from beta carbon, that's why beta elimination reaction.
Pass, sir.
Next, if again it react with sodium amide, sodium amide, sodium. So here you have sodium positive, NH2 negative. So what are the possible products, Sania, in this case?
Sir, Br will react with sodium to form NaBr, and NH2 will means hydrogen will be removed to go with NH2, which will become NH.
Hmm. So this molecule name is sodamide. So again dehydrohalogenation reaction, but in presence of sodamide. Ammonia is a stable product. NaBr is a salt, again a stable product. So what will happen here? It will be CH triple bond CH. So these are the two preparation of alkyne. So if anybody asks me summary, though it is the smallest summary as of now we did, if there are only two methods. One from the calcium carbide, correct? And second from the dehydrohalogenation process, and you have two halogen in the vis form. That's all, correct? Here you use alcoholic KOH and sodamide, and here you use H2. That's all. Okay, enough. Physical property, you already know this. So we are not going to do physical property, but we will do special property. What is not given in the previous topic. Chandana, if you increase number of carbon, what will be the impact on the boiling point?
Increases.
Yes, boiling point increase when you increase carbon. Varinder, what will be the impact on the boiling point if branching increase?
Decrease.
Decrease. This is the universal rule everywhere. Same way, in physical property, you can see कि early member gas, then liquid, then solid. Okay, like here, first three member are gas, then up to next eight member, C up to C11, there are liquid, and after that, like after C12, these are solid. They don't ask this question usually, but they ask this question: कि all alkyne are colorless. This is really important. All alkyne are colorless, and trust me, you will miss it. All alkyne are colorless. Okay, why? Because of the less reactivity. Sorry, they can easily react with any molecule. Less reactivity is present in case of Pratigya. Which hydrocarbon is the least reactive?
Mm,
Hmm, Pratigya.
पता नहीं.
Alkene are least reactive, that's why they are known as paraffin. Correct? Alkene are also known as paraffin. Remember, you will get full chapter, not only this. And why alkyne are colorless even though they can easily react? Answer is al alkyne absorbs specific light alkynes absorb specific light. Only in this light they can form this. Example, they have no chemical group that absorb visible light. And you know, any compound to be colorful should absorb visible light. Correct? तो ये कभी लाइट विजिबल लाइट एब्जॉर्ब ही नहीं करते बिकॉज दे डोंट एब्जॉर्ब विजिबल लाइट और रिफ्लेक्ट विजिबल लाइट. अगर ये विजिबल लाइट ना लेंगे ना देंगे तो कलर होगा ही नहीं. इम्पॉसिबल. सो इफ दे डोंट टेक और दे डोंट एब्जॉर्ब विजिबल लाइट और रिफ्लेक्ट विजिबल लाइट, देयर इज नो कलर. आगे नेक्स्ट, इथाइन हैव स्पेसिफिक ऑर्डर, characteristic order, but the thing is I cannot show you video that ethine have characteristic order. Nobody can show. Correct? So ethine, what I wrote, ethine have characteristic order, but other member are orderless. And you will feel कि sir इसमें special क्या है? Normal ही तो बात है. Yes, it is normal, but in statement this question can be asked कि all alkyne are colorless, and you will feel कि all. Usually these statements are wrong, so I will mark it wrong. But it is correct. Like most of the member of alkyne are having specific order, but ethine is orderless. Then you will realize कि oh, you made mistake. Okay? You made mistake. And last, when it comes to the solubility, Chandana, are they really soluble in water?
No, sir.
Yes, early member can, because they can react with the oxygen and hydrogen bond is possible, because alkyne is highly acidic in nature. But uh, most of the members are immiscible in water, or like you cannot dissolve. Alkyne in small amount you can, but the again issue is